So the value of G is G me upon Re square on a flat non-rotating earth. Now let us do let us discuss now those factors which can affect the value of gravitational acceleration. One is the height. Height means the distance from Earth's surface. So if instead of taking, I know that if an object is taken at A, mg is equal to g mem by Re square. Re is this distance and the gravitational force between them is g mem upon Re square, and this is equal to mg using Newton's second law. If the object is not here, if the object is here, at distance h from Earth's surface, now the gravitational force between that object and Earth is no longer g mem upon Re square. The distance has increased now. If distance is more, the force will be less. So what will be the distance? Re plus h. And what will be the gravitational force? This one. If I assume that the gravitational force here at point B is mg dash, g dash is the gravitational acceleration there, then this mg dash will be equal to g mem upon Re plus h square. From these two equations, I can work out what is the value of g dash. I can divide this by this or just substitute the value of GME. GME is G Re square upon Re plus h square. So it becomes G upon 1 plus h by Re whole square. Now h is more than h is positive always. So this number, denominator, is more than 1. It means g dash will always be less than g. And the reason is the distance has increased. G mem upon Re square. This is the gravitational force when the object is on the Earth's surface, but when it is above the Earth's surface at a height h, then the gravitational force is G mem upon Re plus h square. So now the gravitational force will be less. That's why the gravitational acceleration will be less. So this is the gravitational acceleration now. If h is not very large, then we can use binomial expansion and I can write it as g 1 plus h by Re square, but that's not always, minus 2. Okay, so if h is much smaller than Re, then this will be 1 plus x raised to the power n becomes 1 plus nx, binomial expansion, then this will be the expression. So as we move up, the value of gravity keeps on decreasing. So it means in hilly regions, the value of gravitational acceleration is less than in plain areas. I'm not taking the difference with respect to latitude. We are taking the altitude, the height from the sea level. Okay, now what happens if we go inside the Earth's surface? The value of gravity inside the earth. So variation with depth. So again, if the object is at A, we know the value of F is G MEM upon RE square. M is here, this distance is RE, and this is the force. Okay, now if the object is here at a depth h, see, in order to understand this, I will explain you another very important case. If I keep M at the center of a shell, this is shell, means hollow, uniform distribution of mass, and I keep a point mass M. What is the net gravitational force on this M due to this? It will be zero, because it is equally attracted from all sides. So net force onto it is zero. Every part of the shell is pulling towards itself, but for every part there is an equal and opposite part also. What if the object is not at the center? If it is slightly displaced from the center. If it is here. Now, interestingly, even now the force due to this shell is zero. We can divide it into very small sections, right? And I can take like this. Make this sort of cone. If I take it 3D, you know this angle is actually equal. This is solid angle. And if I calculate the force due to part 1 and part 2, the force due to part 1 is G, let it be M. So M dash or M1 upon this distance, let it be x, so x square. This is the force due to part 1. Force due to part 2, this is G, M, M2 upon, let it be y square, right? Now, what is the mass of this part or mass this part? M1. Total mass per unit area multiplied by area of this part, whatever it is. And same way, M2 will be mass per unit area into A2. So M1, M2 will be some constant into A1, mass per unit area, into, let this constant be sigma A1 upon x square, and this is G M sigma A2 by y square. And how do we define solid angle? Solid angle is area upon distance square. So this area upon distance square, this is the solid angle subtended by this area, and this one and solid angle are equal. It means this is equal to this. If this is equal to this, don't you think F1 is equal to F2? I have given you an idea, though it is not precisely in your syllabus, but even then, just to understand that whenever an object is inside a shell, it does not experience any force because of the shell. Net force is zero. It's quite simple to understand when the object is at the center. But when it is not at the center, then the distance changes, but according to that, even this area is changing, the distance is changing, so the solid angle becomes same due to the opposite part, and then even then the force comes out to be zero. Net force. So okay. Now how will we use it here? So it means when the object is shifted here at position B, this will experience force only because of this part. the external part will not apply any force. We have just seen that whenever an object is inside, so I have broken the solid sphere into two parts. One this inner sphere and another is outer shell. Due to outer shell, there is no force on M. So it is experiencing force only because of this shaded part. Okay. So here it is equal to mg. This is the situation at A. At B it is different because now the force is gme dash upon m, or this becomes re minus h square, and let the value of g be here j dash. Okay. Now what is me dash? G m upon re minus h square. Me dash means mass of this part. Mass is density into volume. For density again, total mass of the earth divided by total density, so total volume, sorry, and mass upon volume. This is density, and multiplied by the volume of this part. Mass is density into volume, and density is again mass upon volume. I have taken uniform distribution, density uniform, that's again an assumption. Okay, so now what it reduces to, 4 by 3 pi is cancelled, and this is square also. So now I have re minus h upon re cube. Okay, now use first and second. Even m is gone. In place of gme, we can write g re square re minus h upon re cube is equal to g dash. So we have g re minus h upon re is equal to g dash, or g 1 minus h upon r. So again, this is a positive number, so less than g dash is less than g. So it means the value of g decreases when we move above the earth's surface or when we move inside the earth's surface. In both the cases, the value of g will be less than whatever it is on earth's surface. Okay, now we can plot a graph giving you all those three expressions. It is on earth's surface, above earth's surface, this is above. It is g upon 1 plus h upon re square, and g below the earth's surface, it is 1 minus h by re. Sometimes we are given, I have taken h from the earth's surface. From here I have taken h, or from here I have taken depth. If the distance is taken from earth's center, then here I can write this slightly different way. Re plus h square upon re square. So it can be written as g re square upon x square, and this can be written as g re minus h upon re. It becomes g x upon re. If the distance is from x is distance from the center of the earth. Okay. So below, if I am taking the distance from the center, here the value of g is 0. As we move up, it is increasing. I have taken the value of g decreases as we move down. At the center, it becomes 0. So at the center, if I am taking g from center, so it is 0, increasing and then decreasing. So what type of graph will we get for x, g? 0 up to re and then. So it is a straight line, it increases and then it is inversely proportional to x square. So here it is inversely proportional to x square, it is proportional to x. So the value of g is 9.8 roughly on Earth's surface, which is flat, non-rotating. If we go above the Earth's surface, the value of distance increases, so the value of gravitational acceleration also increases. In going below the Earth's surface, again the value of g decreases. There are some other factors also. Earth's rotation, that also affect the value of g. That I will take in a separate class. Thank you.